Okay, hello all. In this video, we will talk about something called the principle of similarity. In some video, you will know that you will have used three ways to prove that two triangles are similar. So in this video, we will tell you why these three reasons can be the way that you can prove that they are similar. So we have three ways. First of all, we will go to the first two. The first one is AAA. That means we will have three same size of corresponding angles. The second one will be the three size proportional. That means all the size of this one is in the same proportion. Okay, we have these two ways to find out that they are similar. So what can we do? We will do something that you have learned it before is in your DT lessons. That is, we are going to draw the 3D figures and enlarge it by ourselves. So if we want to enlarge this triangle, we have 4, 5, 6. We can measure it one by one. This is 4. This is 5. This is 6. So we are going to draw the same shape of it. So let's start it from a point here. Okay, I will draw it from a point here. Just any point here. Okay, I draw it here. So we will measure, we will double the length and draw the large size of this one. So this one you will see, I will just measure it here. I do not know, I just draw it randomly. So you will see once again, this is 10 to 7.1. So this is 2.9 cm. So this one is 2.9 cm. So I want to double size this triangle. So we will draw 2.9. So we will go to 5.8. That is 4.2 here. So we will have it here. So this is another point that we will have. This is the making size bigger. I got this one. This is the first point that we will consider. The second one. Sorry about that. We will measure it in from 0. So this is 6.5. Okay, we have 2.9. This one is 6.5. So we have 6.5 cm. I want to make it large, so that I can use 13 cm. So I have this one, and we draw it to 13 cm, and we got here. I want to draw another triangle which is similar to 4, 5, 6, and I want to show that why this works, and we will measure all this angle and even the length of the triangle to show that three sides proportional and the AA is possible to be the answer of it. Okay, now let me draw the last line. That will be here. The 0, 1. This is 7.1 cm. Okay, this is 7.1 cm. So we will double it. That means this is 14.2. So that we will draw. Okay, let me move it a little bit lower. So you will see I draw it like this. And then the last one is here. So we make the new triangle. Let me draw it and show it to you. This triangle is I'm going to show is this one. 1, 2, and 3. So they are similar. So you have this triangle and this bigger triangle. Both of them are similar. Okay, now what I'm going to do is that I want to show that all the length and angle are all the length in proportion and all the angles are equal. So let's check the AAA first. Well, now let's look at this angle. The angle for this one here, you can look at this one. This is about 41 degree, about 41 degree. Okay, so we write down first. This one is about 41 degree. So we measure this angle once again. With the same shape, you will see once again, this is 41 degree once again. So I think that these two angles are equal. Next, we are going to measure the other angle. Okay, the other angle here, I move it a little bit upper. You will see the angle here is a little bit short, but I can see that this is about 81 to 80. I think this one is 82. So we can choose this one is 82 degree. And after we measure this angle, this time obviously, you will see this is a little bit close to 82 degree once again. Okay, this is 82. So this is 82. So the last angle, I think that you can calculate by angle sum of triangle directly. This is 1, 2, 3. So this one is 57 degrees. So I can say this one is also 57 degrees. So you can say for the same shape angles, you will see these three angles are equal. So AAA is a way for you to prove that they are possible. So AAA is okay to prove that they are similar. Okay, now next one, I will measure the length of the bigger triangle here so that you will see they are in proportion. Okay, now let's go to the longer side first. For the longer side, you will see luckily this one is 11 point something. Here, let me measure it carefully. And also this one. Yeah, okay, let's do it. First of all, this one is 11.7. Okay, so I will say this one is 11.7. Okay, almost. And then we will see this one is 9.6. 9.6. And finally, you will see the last one is 7.7 something. 7.7 cm. Okay. So we have something like this, and if you can use your calculator, you can find out that this three will follow the ratio of 4 to 5 to 6 because you use 6 over 11.7 is close to 0.5, and 5 over 9.6 is obviously right, and 4 over 7.7 is almost go to 1 over 2. So that I think the second one is 3 sides proportional is also we will have the same way to show that they are similar. This one is not clear, but you can use your calculator or even you can do it by yourself to check these three ratio is almost equal. So I think that 3 sides proportional is another way that you can prove that they are similar. Okay, now next. Another similarity is the ratio similarity. Is the ratio of 2 sides include angle. Okay, now to make it easy, if I want to prove that they are similar, why don't we overlap it? So first of all, let's draw it one by one. We draw a first for example, I draw it for 5 cm first, and then 10 cm for the second. So I mark it here. This is 5. Okay, we have this point as the angle, and we choose the angle is 40 degrees. Okay, the second one is 40 degrees. Here, I choose here, and I choose the length here is 4 and 8 for the length here. So we will have 4 and 8. So this is up. Sorry about that. I must mark the 4. This is 4. Okay. Now, why do I do this? Because this is 40 degrees, and I know that this one is 5 cm, and this one is 4 cm. So I think that I can draw this line immediately. And I also draw this one is another 4 cm, so that means it's totally 8 cm. And this one is 5 cm, this is totally 10 cm. So both of them with the ratio is double. This is 2. So if I use the ratio over there, so I also draw these 2 straight lines. So that why can we show that these two triangles similar is that if I can turn it back to AAA directly, so I can solve the problem easily. So what can we do? In case it's not difficult, the only way I can do is that these two lines are parallel. If we know that these two lines are parallel, so that I can say these two angles are equal, these two angles are equal, so I can say this is just similar to AAA. So why don't we prove that this is similar? This is parallel. So I will put this here, I will put the length here, and I will put another ruler here. If it's parallel, I will move it here, and so you will see this one will just touch here the same way. Once again, this is a ruler, and you can say we move here, they are parallel here. So you can see these two lines obviously parallel. So because they are parallel, so I know that these two angles are equal. These two angles are equal. Even if you don't trust me, you can measure it by the protractor. Once again, this angle, I take a ruler first, is equal to about 53 to 54. 53 is right. It's a little bit close to 54, I think. So let's measure this one. This one is, okay, once again, we have the problem. 53. So this one is also 53. I think this one is 53, not 54. I looked it wrong, I think. Okay. We protractor here. Okay, this one is 53, I think. So we have the same angle. So we will see ratio of two sides include angle is another way to show that they are AAA. In case it's easily to show that they are AAA. So this is the other way that why ratio of two sides include angle can prove similar. So in this video, I hope you all know how to do is that why AAA, why three sides proportional, and even why ratio of two sides include angles can be the reason that proves similar. So hope you all know how to do this, and thanks for watching. Bye bye.